In recent lessons, we've been talking about polynomials being formed by multiplying together binomials, creating a quadratic trinomial. Let's take, for instance, 2x plus 5 times x minus 7 and multiply those together. Well, we taught you the area model way, so if we just create an area model and put on the outside the two binomials on the sides, and then multiply inward to say 2x times x then becomes 2x squared, 5 times x becomes 5x, and 2x times negative 7 gives me negative 14x, and 5 times negative 7 gives negative 35. We empty the box and we get 2x squared plus 5x minus 14x minus 35. And this has 4 terms, but we can reduce it down to 3 terms because the two middle terms are like terms, and we can combine them. 5x plus negative 14x gives negative 9x. And so we can rewrite then this product of two binomials into what's called a quadratic trinomial. Quadratic because the variable x is squared. 2x squared minus 9x minus 35. This is the product, and if that's the product, then that means that the factors are 2x plus 5 and x minus 7. If we have a product that is factorable, then we can actually take this product right here and break it down so that it becomes the factors 2x plus 5 and x minus 7. So that's what we're trying to teach. How to take a product and break it up into the factors of a quadratic trinomial that is factorable. This is like taking 56 and knowing that that's made up from 7 times 8, where 7 and 8 are factors then of 56. So right now we're talking about factoring a quadratic trinomial when a is equal to 1. Now when I say a, I'm talking about the coefficients of each of the terms. Notice the coefficient here of the x squared term is 1, so a is equal to 1. B is negative 4, and c, which is the constant, is negative 45. So the thing that we start with is always to draw a big X and take the first coefficient, which is 1, and multiply it by the last coefficient, which is negative 45, and get negative 45. And then we take the second coefficient, which is negative 4, and now starts our search for two numbers. We're looking for two numbers now that multiply to the top number, and so we have negative 45, and those same two numbers need to add to negative 4. Two numbers that multiply to negative 45. Well, there's 1 and 45, 3 and 15, and there's 9 times 5. So those are all the factor pairs that I can think of that might fill in the sides there. Now the thing to pay attention to is that we need a negative 45. So one of those two numbers has to be negative in order to get there. I'm going to use the 9 and the 5, and you'll see why. Because when I say 9 is negative, now I have negative 9 times 5 gives me negative 45. And negative 9 plus 5 gives me negative 4. So we've done it. When a is equal to negative 1 in factoring a quadratic trinomial, we're done here. Because all you have to do now is write the answer as x minus 9, there's the found numbers there, and x plus 5. And we're done. So now here we're talking about factoring a quadratic trinomial when a, the first coefficient of the variable x, is not equal to 1. So a is not equal to 1. In this case right here, a is equal to 2. And b is equal to negative 9. And c, the constant, is equal to negative 35. So what we do with the magic x is when we load it up, we always put the product of the first coefficient 2 times the last coefficient, negative 35, and we get 70. So that's why we have 70 loaded up here. And then the second coefficient, the negative 9, ends up down here in the magic x. Now we're looking for two numbers that when I multiply them, I get negative 70, and when I add them together, I get 9. Well, we have to consider the factors of 70. So here's 70, and let's go for maybe calling that 2 and 35. Well, I don't see a difference of 9, so I think I'm going to move on here. How about if I give 7 times 2, and I get 14, and that leaves 5 over here. So 14 times 5 is 70, and I think I actually have it now. So if I take 14 and 5, I'm wanting one of them to be negative so that we've got negative 70. Well, let's let that equal to negative 5. Negative 5 times 14 is negative 70, but 14 plus negative 5 is not negative 9. Well, that's easy to resolve. How about let's make that negative 14 and 5. Well, negative 14 plus 5, that's negative 9, so we got what we wanted. So now we're going to go to using an area model. And the area model is going to look like this. On the inside, we're going to load it specifically this way. The first coefficient, 2x squared, is going to go in the upper left-hand part of the box. The last term, negative 35, is going to go down here in the lower right-hand corner. In the two other spaces, it doesn't matter the order in which we do this, but we put the two found numbers, so I'm going to take negative 14 and combine it with our variable x, and I'm going to take 5 and combine it with x and put that in the other point right there. Now, I'm going to go ahead and just fill this blank right here with a factor that I see in both 2x squared and negative 14x. Well, I see 2 and I see an x. So it's 2x. And then everything else becomes just working backwards in filling the area model. So what times 2x gives me 2x squared? That's going to be x. Now, if I fill the space to the right of that, now I'm asking the question, what times 2x gives me negative 14x? And that becomes negative 7. And x times what gives me 5x? Well, that's going to be 5. And then 5 times negative 7 gives me negative 35, so that checks. And so what this tells us is that we use the area model backwards now, and we're really representing x minus 7 times 2x plus 5. And there we have it. We factored our quadratic trinomial, and there are the two factors in the form of two binomials. Here's another method of factoring a quadratic trinomial, this time just simply using the splitting the middle term method. You see, negative 14 and 5 give you negative 9, so we can split that middle term and write it this way. 2x squared minus 14x plus 5x minus 35. Now, if we break this up, we can do this into two sets of parentheses, and we can factor out common factors from each of those binomials. So I have 2x gives me x minus 7 plus 5 times x minus 7. And now what I've done is I've created a group x minus 7 and x minus 7 that can be factored out of the larger expression. And notice what we get here. We get 2x plus 5 times x minus 7. So that's called factoring by grouping. Now, we're factoring a quadratic trinomial when a is not equal to 1. And this is yet different way of doing it. Now, we always start with getting the magic x, and so I've gotten the magic x, and we already got our two found numbers, negative 14 and 5. But now I'm going to show you a graphic organizer. And the graphic organizer looks like this, where I draw this and I put a fraction bar right here, and I put a box on the outside, and I'm just going to do two of those. So I'm just going to copy this and put it right next to it. So now what we're doing is we're going to take our leading coefficient, which is the 2, and put it down here. And when we do that, we're going to take the two found numbers and we're going to stick them right here on the tops of those fractions. And then we're just going to put x plus and x plus inside our graphic organizer. And now what we do, the next step is to just simply reduce the fractions. So here we get x plus negative 14 over 2 gives me negative 7. And over here I get x plus, that one's already simplified to 5 over 2. Inside these boxes is really what we're going to multiply our binomial by in order to obtain flattened fractions. Meaning I'm going to multiply just by 1 here because this is just x minus 7. And then I'm going to multiply by 2 here because that flattens that fraction. When I multiply 5 halves by 2, I get 5. So this just becomes 2x then plus 5. All of a sudden, we're done. So this is a graphic organizer that helps us, and I'll show you how to do that with another problem. We're going to do that graphic organizer method again, only this time we're going to be using a trinomial that is a little bit more complicated. So we always start off with draw a big X. So here it is, draw a big X. And we load the top with the product of the first coefficient, 6, and the last coefficient, negative 12. 6 times negative 12, negative 72. And the coefficient from the second term is negative 1. So now we're looking for two numbers that multiply to 72 and add to negative 1. So let's just try a few things. So 72. How about 4 and 18? 4 and 18 gives me 72, but I don't see where I can get a negative 1 when I add or subtract these. How about let's try something else. Let's take 2 more from 18 and get 8, and then take that 2 away from 18 and give me 9. 8 times 9 gives me 72. And the difference of 9 and 8 is negative 1. So I can say 9, 8, and when I add them together, I want negative 1, so let's make that a negative 9. So now I have negative 9 times 8 gives me negative 72, but negative 9 plus 8 gives me negative 1. All right, here's how we use that graphic organizer now. We have a fraction part in there, and we load the fraction with the coefficient of the first term. So there's a 6, and there's a 6. And then we take our two found numbers, negative 9 and 8, and we put them right here in the top of that fraction, negative 9 and 8. The next step is to reduce those two fractions. So both of those can be reduced, and so we're just going to copy them down and then pull out what we can to reduce them. So 9 over 6, there's a 3 in the top and a 3 in the bottom, so when we pull that out, I end up with negative 3 over 2. And 8 and 6 have 2 in common, so let's get 2 out of 8 gives me 4, and 2 out of 6 gives me 3. Now, that gives me the clue for what I'm going to multiply these two binomials by. I'm going to multiply this one by 3, because that's going to flatten that fraction, the 4/3, and turn that into a 4. And I'm going to put a 2 right here, and that gives me negative 3 over 2. Look at what happens when we multiply in those numbers. 2 times x is 2x minus 3. And 3 times x is 3x plus 4. And we're done.